Hi guys. Have you ever wondered how machines can learn from data and make predictions just like humans do? Well, you're about to dive into the fascinating world of machine learning with Python. Welcome. I'm S.H. Chaudhary, and in this video, we'll explore how Python is revolutionizing the field of machine learning. By the end of this introduction, you'll understand what machine learning is, why Python is the go-to language for ML, and how you can get started. This session explains and discusses basic concepts of machine learning and its real-world applications. So, what is machine learning? At its core, machine learning, or ML, is a way for computers to learn from data and improve over time without being explicitly programmed. Instead of writing code for every possible scenario, we let the machine learn patterns from the data. Machine learning, ML, is a subset of artificial intelligence, AI. It involves training computer systems to learn from data and improve their performance on specific tasks without explicit programming. It relies on algorithms and statistical models to analyze patterns in data and make predictions or decisions. In essence, ML enables computers to learn and adapt based on experience. This makes them capable of performing tasks such as image recognition, speech translation, and more. Example: for instance, when you get movie recommendations on Netflix, or when your email filters out spam, that's machine learning in action. ML is everywhere, from self-driving cars to voice assistants like Siri and Alexa. Machine learning can be broadly categorized into three main types. 1. Supervised learning. 2. Unsupervised learning. 3. Reinforcement learning. One. Supervised learning. The model is trained on labeled data, meaning the input comes with the correct output. The algorithm learns to map inputs to the correct output. Examples include classification, example, email spam detection, and regression tasks, example, predicting house prices. 2. Unsupervised learning. The model is trained on unlabeled data. The system tries to learn the underlying patterns and structure from the data without explicit guidance. Examples include clustering, example, customer segmentation, and dimensionality reduction. Three. Reinforcement learning. The model learns by interacting with an environment and receiving rewards or penalties based on its actions. It's commonly used in game playing and robotics. How ML works. Machine learning models work by learning from data. Here's a simple breakdown of the process. 1. Collect data. First, we collect a data set. It could be anything: numbers, images, or text. Here is an overview of dataset. Explanation of the columns. Bedrooms. Number of bedrooms in the house. SQFT. Total square footage of the house. Location. Coded as 1 for urban and 0 for rural. Age. Age of the house in years. Price. The price of the house. Target variable. 2. Prepare the data. Next, we clean and prepare the data, making sure it's in a format suitable for training. 4. Splitting the data set. Step. Divide the data into a training set and a testing set, commonly 80% for training and 20% for testing. 4. Choose a model. We then select a model, such as linear regression for predicting house prices or a neural network for recognizing handwritten digits. 5. Train the model. The model learns from the data by finding patterns and relationships. This process involves adjusting parameters to minimize errors. 6. Make predictions. Finally, we use the trained model to make predictions on new, unseen data. Applications of machine learning. 1. Healthcare. Disease diagnosis. ML models can analyze medical data to detect diseases like cancer, diabetes, and heart conditions. Medical imaging. Algorithms can improve the accuracy of reading medical images, e.g., X-rays, MRIs, to identify abnormalities. Personalized treatment. Analyzing patient data to suggest personalized treatment plans based on genetic and clinical factors. Predictive analytics. Predicting patient outcomes and hospital readmission rates. Two. Finance. Fraud detection. Identifying suspicious transactions and fraudulent activities using pattern recognition. Algorithmic trading. Using ML models to analyze market data and execute high-speed trading. Credit scoring. Assessing the risk of lending money to applicants based on their financial history. Customer service. Implementing chatbots and automated customer service solutions. Three. Retail. Product recommendations. Recommending products to customers based on their browsing and purchasing history. Example, Amazon, Netflix. 4. Inventory management. Using ML to optimize inventory and supply chain logistics. Customer sentiment analysis. Analyzing customer feedback and reviews to improve products or services. Dynamic pricing. Adjusting prices in real time based on demand and other factors. Four. Transportation. Self-driving cars. Autonomous vehicles use ML to interpret sensory data and make driving decisions. Route optimization. Applications like Google Maps use ML to provide efficient routes and estimated travel times. Traffic predictions. analyzing traffic patterns to predict congestion and suggest alternate routes. Let's explore more applications of machine learning. 5. Computer vision. Object detection. Identifying and classifying objects in images and videos. Augmented reality, AR applications like Snapchat filters and AR-based games like Pokemon Go. Facial recognition, used for security and identification purposes, such as unlocking phones and monitoring security cameras. Six. Manufacturing. Predictive maintenance, using sensor data from machines to predict failures before they happen. Quality control, automated visual inspection to detect defects in manufacturing processes. Seven. Agriculture. Yield prediction, predicting crop yields based on weather data, soil health, and other environmental factors. Precision farming, optimizing the use of resources like water and fertilizers based on data analysis. Crop monitoring, using drones and ML algorithms to analyze crop health and soil quality. Eight. Cybersecurity. Threat detection, identifying potential security threats and malware using anomaly detection. Spam filtering, filtering out unwanted or harmful emails using ML models. Machine learning continues to evolve, with research pushing boundaries in areas like deep learning, natural language processing, and reinforcement learning, making it one of the most dynamic and transformative technologies today. Let's explore one simple application titled House Price Predictor App based on machine learning. Here's a simple Python Flask code snippet for a house price predictor app that uses a linear regression model. This app takes user input for features like the number of bedrooms, square footage, location, and age of the house to predict the price. This is a simple and interactive Flask app for predicting house prices. Let's explore the Python code developed in Visual Studio Code for House Price Predictor application. Remember, Flask in Python is web development environment for developing web applications. Here's a simple Python Flask code snippet for a house price predictor app that uses a linear regression model. This app takes user input for features like the number of bedrooms, square footage, location, and age of the house to predict the price. Recall the first step is to load the dataset. After step of cleaning and preparing the data, the third step is to split the data into train and test dataset. The next step is to train the mode using training dataset. Here regression model is used. Here is the Python code, which when run, executes the application. After training, start predicting the price of house using ML model. The various input parameters in the dataset is accepted using an HTML form in a web page. Let's activate the virtual environment created to run and test the application created. Once activated, run the app.py file to launch the website created. The application is in the development phase, so to test it on development machine, one requires a development server. This is the local internet address of the local web server running on port number 5000. Clicking on Control key plus click opens the home page of the application. Here is the home page with the HTML to accept the different parameters required to predict the price of the house. Let's input some values of the parameters to predict the price of the house. Click on the Predict button. We'll call Python code specified in the action attribute of the form tag. Here is the predicted price. Here is the dataset used to train the model. Now let's try for some other values as well. It's working. You can adjust the values or add more records to improve the quality of your model. Make sure the data is realistic and relevant to the features you want your model to predict accurately. Thanks for watching. Don't forget to like, subscribe, and hit the bell icon if you found this video helpful. Drop a comment below if you have questions or suggestions for future topics. Happy coding! Thank you again, guys, for watching the video. Please visit my blog for details.